Welcome to the Explainer. Today, we're going to peel back the layers on a new kind of database that's really powering the next wave of AI applications. We're talking about the engine behind the curtain, the thing that makes modern AI not just smart, but actually, useful. So let's start with a puzzle. Your standard traditional database is awesome at finding exact words. You type dragon, you get stuff with the word dragon. Simple. But what if you want to search for a concept, or an idea, or even an emotion? How in the world do you tell a computer to find a triumphant moment in a movie? Well, the answer is you have to move beyond just matching keywords and get into something way more powerful, semantic search. So instead of just looking for specific words, semantic search is all about finding the meaning. It gets that when you search for dragon, you might also be interested in stories about mythical fire-breathing reptiles. And this is absolutely crucial for AI applications like retrieval augmented generation, or RAG. Now, that's just a fancy way of saying that an AI, like a chatbot, doesn't just use its built-in knowledge, it actually goes out and pulls in fresh, relevant info from a database to give you a better answer. And semantic search, that's the tool that finds that perfect, context-rich information. Okay, so how does this magic work? Well, at the very heart of semantic search are these things called vector embeddings. The easiest way to think about them is like a universal translator. They can take pretty much any unstructured data, a sentence, a photo, a sound clip, and turn its essence into a big, long list of numbers. So once everything is turned into these numerical fingerprints, special databases can do what's called a vector search. Imagine a massive, complex map, but instead of just north, south, east, and west, it has hundreds of dimensions. The database isn't looking for an exact match, it's looking for what's nearby. Things that are close to each other on this crazy map are similar in meaning. So how do people actually, build with this stuff? Well, as you might guess, a whole ecosystem of tools has popped up to handle this exact task, and each one has its own pros and cons. And what's really interesting here is the spectrum of options you have. On one end, you've got these lightweight libraries like Face, which are awesome for smaller, static projects where you want total control. But on the other end, you have these full-blown, purpose-built databases like Milvis or Weaviate, and they're designed for massive, constantly changing datasets that you'd find in a huge production app. This brings us to the next layer of complexity, because modern AI doesn't just deal with words, right? It has to make sense of a world that's just full of images and audio and video. And this is the world of multimodal data. The real challenge, and honestly, the magic, is getting all these different formats to speak the same numerical language so you can search across all of them together inside a single system. This process is just fascinating, especially when you think about something as complex as video. You can see how this system literally pulls meaning from what you see in the video frames and what you hear in the audio, and then it merges them into one single supervector that represents the whole meaning of that clip. And this is where it gets really, really powerful. It enables what we call cross-modal search. This means you can type the words red sports car and find images of red sports cars, even if those words are nowhere in a caption. The system is smart enough to see the semantic link between your text and the actual visual content. It's amazing. Okay, but here's where we hit the final and maybe the most critical layer for building apps that people can actually use. It's great to search for renewable energy, but what if you only want articles published after 2023? The solution for that is called hybrid search, and it is truly the best of both worlds. You get that nuanced contextual understanding from the vector search, but you combine it with the sharp, surgical precision of old-school filtering on stuff like dates, prices, or categories. Just look at the difference here. The semantic query is broad. It's like casting a wide net. The hybrid query, though, is powerful. It lets you find all those semantically similar results and then slice and dice them with exact filters. It's how you get exactly what you're looking for. And this capability is what makes modern AI systems truly practical. For e-commerce, you could search with a picture of a shirt you like, but filter the results to only show ones that are in stock and under $50. It's what separates a cool tech demo from a useful, reliable tool you'd actually want to use. So when you combine all of these layers, the semantic search, the multimodal data support, and that crucial hybrid filtering, you finally arrive at the database architecture that really defines modern AI. And here it is, the hybrid multimodal database. In a nutshell, it's one system that can do it all. You get all the awesome benefits of using different specialized databases, but you get to skip the operational nightmare of trying to manage and synchronize all of them. Of course, choosing the right solution for this isn't exactly simple. You've got to balance these critical factors, like can it scale to billions of items? How fast are the queries? And what's the overall cost? There's always going to be a trade-off between pure performance and how much of a headache it is to manage. And check this out. Here's some fantastic real-world perspective from a developer discussion on Reddit. The user points out that for a lot of AI apps, especially RAG, the time it takes the vector database to do its search is often just a tiny little fraction of the total wait time. The big bottleneck is the LLM itself thinking. And this leads us to what is probably the single most important takeaway from all of this. Don't get lost in isolated benchmarks. You have to look at performance in the context of your entire application. Saving a few milliseconds on a database query is completely meaningless if the AI model itself takes a full second to generate a response. Look, as AI gets more and more sophisticated, the data infrastructure underneath it has to evolve just as quickly. This move toward hybrid, multimodal systems isn't just some passing trend, it's a fundamental shift. So the real question to ask yourself is your database strategy ready for what's coming next?